Let's take a look at this question here where they're asking us to take the indefinite integral of ln x cubed. So this is not ln of x cubed, but it's the entire ln x to the power of 3 divided by x and integrating with respect to x. So what we're going to do is we're going to use the substitution method on this. And the first part of any substitution method question is to figure out what you should be substituting in for. You figure out what u equals. And in this case, what we're going to do is we're going to choose u is equal to ln x. And the reason we want to do that is because we take a look at the question, and if you take the derivative of this choice of u, so du by dx is actually 1 over x. And you see here this 1 over x is actually sitting here. So it's usually a good idea whenever the derivative of your choice of u is in the question, or a multiple of it is still in the question. That's usually a good indication that that's the u that you should be choosing. So we're going to choose u is equal to ln x. So that means this is my original problem, ln x cubed over x dx. And just doing a straightforward substitution, I'm going to just sub in what u actually is. So this becomes u cubed over x dx. So I've done nothing here but just replace the ln x's by u's. Okay, so now I'm in the situation where I have both u's and x's in my problem, and I would like to get rid of them. So what I'm going to do is I'm going to go over to the side here, and I'm going to take the derivative du by dx. And what I notice is that that's 1 over x. And even though this is not a fraction, if I treat it like a fraction and solve for dx, that'll end up helping me solve my problem. So I'm going to pretend that this is a fraction and solve for dx. This becomes du is equal to 1 over x dx. And if I isolate or solve for dx by multiplying both sides by x, I end up with dx is x du. So now in my problem, I can replace any dx I see by x du. So I'm going to go ahead and do that. U cubed over x, and then the dx is replaced by x du. And now I see why I liked choosing this version of u is because this x that was in the question is now canceled out with this x from the derivative, and I'm just left with the antiderivative of u cubed du. I can use some antiderivative formulas for this, and so what I end up with is u to the power of, well, when you're taking an antiderivative of something that looks like this, you raise the exponent by 1. So 3 plus 1 is 4. And then I also multiply by 1 over the new exponent. So 1 over 4. And then, of course, I add my arbitrary constant. And now what I can do is, because the question asked us in terms of x, I can go back and replace all the u's with what they actually are in terms of x. So I'm going to replace the u's by ln x. And at the end of the day, I get 1 over 4 ln x to the power of 4 plus this arbitrary constant, and this is the final answer.